Okay, hello guys. I'm Dr. Sean Thompson, and I've been teaching and studying meditation I've been studying meditation for almost 40 years, and I've been teaching it for about 20. And one of the things that I got very interested in, being a doctor, I work a lot with neurology and some neurological issues, and I'm very interested in the way the brain is and the way the brain changes during meditation or with meditation over time. Now, I even had an MRI done of my brain, which I'm going to go over a different time. We're going to look at different areas of my brain in the MRI and see if we can see any differences. Now, that means I'd have to go through the whole bunch of other people with quote unquote normal brains. Now, figure I've done a few hours a week of meditation for the past 30 years. That's going to be quite a bit. And I think that that's formal sitting meditation with a timer kind of thing in my meditation space or in my class or with the classes or something like that. But I also do a lot of meditations on the sides. So the thing I'm interested in, and one of the things I want to look at, is the different parts of the brain. Now, the brain is about, let's see, there's a good picture of the brain. You can see it right up here behind me, like all these little pictures behind me here. The brain sits in a thing called the cranium. And that's this guy here. The cranium, right, is made up of a bunch of different bones that all link together with these little areas here called sutures. We have four main areas that we want to look at. Number one, the frontal bones, the parietal bones, the temporal bones, and the occipital bones. So when we open up the brain, or we open up the cranium, right, that's the skull, we open it up and take the top off, we're going to find our brains. And it weighs about 3 pounds in a real human brain. It's covered in a fluid, and this other covering over here, which we see these bumps and these grooves and stuff like that, the grooves are called sulcus or sulci if they're a plural, and a gyrus or gyri if they're these bumps on the outside. Now, how does that work? Well, figure that the cerebral cortex, the covering of the cerebrum, which is the brain, is about 17 inches by 17 inches wide either way. 17 inches squared is about 300 inches of space that we want to fit into a small, into this cranium or into this cranium, right? So in order to do that, we're going to have to fold up the different pieces. Now, I have around here somewhere, there we go. This is about how thick, okay, your cerebral cortex is. This is 2.5 millimeters, okay? In some people, it gets to be about 3. In some people, it may be less. In certain areas of your brain, it's going to be more depending on how much you use it. And in other areas, it'll be less depending on how much you don't use it, right? Now, if you look at the gyri, those are the lumps that go up, okay, and we can see them. And then inside, we would have the sulcus, which would fold in like this. So sulcus, gyrus, gyrus, right? And sulcus. So that way we can fold, look at how we fold this up. We can fold that up into a much smaller space now. Same thing with the brain. We're cramming all of this into that small space. Now, inside of that little layer, that 2.5 millimeter layer, right? That little teeny layer is all white matter. Gray matter, okay, which is the unmyelinated, which means it doesn't have an insulation on it like a fatty insulation called the myelin sheath. If it doesn't have that, we get a really quick arcing and a really quick information movement in those. So as the gray matter out here, these impulses move at about 5 or 10 meters per second. So how big is a meter? A meter's 3 feet. So we're talking 15 feet. That's 5 meters to 10 meters to 30 feet every second. Zoom, that's pretty quick. But if you insulate them, you get even faster. You can get up to 150 meters per second. And that's really, really quick to get information from other areas inside the brain. Let's say inside the brain here. We're moving around inside, deeper inside of all this stuff, inside the, I guess you'd call it the meat of the brain, the white matter of the brain. That's where interconnections are made in what are called interneurons. Interneurons talk with different places. So you may have a thought or some idea of something that happens to your hand, and that for this hand, the information's on this side of my head. Actually, it's down low in this side of my head, and that may have to talk to as I'm putting it in my mouth, where my mouth is. So these are internal things. And then we're going to connect with taste and all this other kind of stuff. So, what is it about the cerebral cortex that we find so interesting with meditation? If we use Einstein, Albert Einstein, as an example, he was a brilliant guy. And when he died, scientists wanted to have his brains, and they wanted to take apart his brains, and they wanted to see what part of his brain, what part of this thing was responsible for physics, what was responsible for math, what gave him his brilliance. So they went and they dissected the entire thing and they looked at the entire thing. And the only area that they did find that had more convolutions, that's going to be the sulcuses, the down dipping pieces, and the gyrus, the upper, lumpy bits that you can see up on this picture right here. The lumpy bits, right? Lumpy bits and gyri was for the left hand. Well, wait a minute. What did he do? He was a right-handed guy. He would write right-handed, but what he would do in order to think and calm down is play the violin. The violin uses the left hand for the strings and the frets. I don't think there's frets on those, but anyway, there's, to move around and to do the different notes, and the other hand would move back and forth, so that wasn't quite as developed as they had expected. The left side of the brain was way more developed. Now, it wasn't any more developed than a good violinist, for example. So they never really got the question. A lot of his brain pieces did disappear. Some people say they have them. They're probably sitting in a lab somewhere, or have been discarded because no one knew what they were. So we're going to start with not only the cortex, because that does thicken in certain areas when people meditate more. It also changes in a little bit of its depth, which is the same as thickness, really, right? But also the convolutions, the gyri and the sulci. Now, other areas of the brain that are really interesting would be like the amygdala. The amygdala is an area of the brain we know is related to fear and aggression. It's a very, very, like we consider a very primitive part of the brain. And here's where it is. If we take the brain and we pull off the cerebrum, this is the main part of the cerebrum, and we're going to get in here a thing called the diencephalon. Diencephalon means two parts inside the ceph. Right, inside the brain. If we look at it from this section, we can see all this whole thing here rolls around, and the amygdala is right down in here. I don't know if you can actually see that very well, but the amygdala is right down in here. So right about straight in here and straight in there. If we cross those two, we'd probably get pretty close to where my amygdala is. And what we know about this is when people have more meditation and they've practiced more meditation, especially things like loving kindness, calming meditations, breath meditations, stuff like that, the amygdala actually shrinks. It gets smaller. It gets less vibrant, less activity in there. How do we know this? We've done meditation screenings on people, which are called functional MRIs, and those allow us to see the glucose uptake or what's going on inside the brain where there's more metabolism. And if there's less metabolism in an area of the brain, we know that there's less going on there. If there's more metabolism, there's more going on. So people that have anxiety and stress will have higher amounts of activity in the place called the amygdala. Now, as they meditate and they become more calm and they become more relaxed, and this is just one benefit of that kind of practice, the amygdala itself will decrease in size. So, how does this happen? When we're increasing our meditative processes, we're increasing looking at the self, really is what you're kind of doing many times. You're looking at how you respond to things and what your reactions are to things and what your mental formations, your consciousness, and your uh, um, different forms and feelings and perceptions and all of that stuff are. When you're looking at itself, we start to affect the frontal brain lobes, the prefrontal cortex. And we know this is kind of where the personality is. And we know that as we meditate more, that actually gets thicker in that part of the brain that's up here. Now, we then have to look into some of the theories as to why. Now, one of the old sayings, or kind of a new saying actually, is the neurons that fire together wire together. So what happens is the more association things you make together with different parts of your body. So for example, playing ping pong or something like that, it would be like visual hand-eye coordination. Those things would have to be really, really connected in order to be very good at that sport. So there was a psychologist, Donald Hebb. It's called Hebb's law, which is the neurons that fire together wire together. And that's where we get this theory that things, as they start to build, we start to get more active. So that gives us a couple ideas. Number one, we know now a few parts of the brain. So this is important because I think with meditation, as you start to get deeper into it, you're going to want to know why. And I always want to know why and how. But I'm going to approach it from what the brain is doing. I mean, are we able to change actually the the structure. This is the anatomy of the brain. We know we can change the physiology of it, and the physiology of the brain is going to be things like neurotransmitters, different amino acids, how the brain moves the nutrients to and from those neurons, how the blood flow is affected. We know that that changes with certain types of activities. Now, it's reasonable to assume that meditation is going to change the brain. We already know for a fact that it does. We have the big area that we talked about, that's the cerebral cortex. We know that it thickens in the front, which is the frontal lobe. That's our planning area, that's our personality, that's our kind of like higher thinking area. We also know that it shrinks down the amygdala, which is responsible for fear and anger. So we're going to go over as we go. Don't forget to like and subscribe, I guess, to see if you want more of these kind of things, because I am going to go over my own brain in the MRI. It's going to take a long time because I've got to set a bunch of stuff up and look at some other things. But we're going to work also with this cool and groovy little plastic brain that I have. And I want to go through and show you the different sections of the brain, not just for the anatomy's sake, but also for the physiological sake, and how meditation, contemplation, and higher thinking and activities, things like even basketball playing or something like that, will change the way the brain looks and the way the brain acts and the way the brain works. And the process of the neurons that fire together will wire together. So we have pruning that goes on, and we have reconnections and new connections and increases in metabolism in areas that we use more of. That's what I want to get into. So if you have any questions, go down to the comments there. You can also follow my blog, which I kind of do a few other things with that, but I'm using that more for the scripts for this kind of video stuff. I'm branching out from the ideas that I've had, because I want to now take some of the Buddhist meditation techniques and let's apply them to physiology and let's apply them to anatomy, because there's no reason they shouldn't. Everybody always says that Buddhism follows science and science will tend to agree with Buddhism. I find that this is true most of the time. We're going to explore some of that. So in the Mahasatipatthana, in the other sutras that the Buddha has professed and talked about vipassana and samatha and different dzogchen and all these really cool meditative techniques and psychological and philosophical ways of being. I want to try to connect anatomy and physiology to those ideas. Anyway, this is Dr. Sean over at either the Center Path or the Natural Body Works. I'll probably set this up on both of those channels if I can. I don't know if you can do that, but we'll see what we can do. And let's find out more about what we can do about the brain and learn about the brain better.